Let's continue with section R.7, Rational Expressions. Example 2. Find all numbers that must be excluded from the domain of the rational expression. So recall what we were told before about finding the domain, that we are to set the denominator equal to 0, solve, and then exclude the results from the domain. So in other words, we've got to find out what numbers, and what this means is what values of x would make the denominator 0. Then they must be excluded from the domain. So we'll set our denominator, x squared minus 16 equal to 0, and solve. I'm going to factor this as x minus 4, x plus 4. Remember, this is a difference of squares. If we FOIL this, the middle term will disappear, and we'll have just x squared and minus 16. Now we take each factor, set it equal to 0, x minus 4 equals 0, and x plus 4 equals 0, because if this times this, x minus 4 times x plus 4 is 0, then at least one of those has to be 0. So we just say it is and find out what makes that happen. So here x equals 4, and here x equals negative 4. So the numbers that must be excluded from the domain of this rational expression are 4 and negative 4. So let's try it again for this one. Notice we did nothing with the numerator. As we saw, the numerator can be 0, no problem. Okay, set the denominator equal to 0, x squared minus x minus 12 equals 0, and solve. I'll solve by factoring. Factor this, x, let's see, what would that be? X minus 4x plus 3. Yep, I think that works, equals 0. So x minus 4 equals 0, and x plus 3 equals 0, x equals 4, and x equals negative 3. So those are the two values of the variable x that must be excluded from the domain of that rational expression. Okay, let's look at example 3. All right, we are to, in this part, what's happening now is multiplication and division of rational expressions. And the rules for multiplying and dividing rational expressions are the same as the rules for multiplying and dividing rational numbers, which are also called fractions. All answers should be simplified to lowest terms. So we do this just like we would do with fractions. So if we want to multiply, all you do is multiply across, right? No common denominator required. Numerator times numerator, denominator times denominator. However, we want to simplify, right? So that includes factoring in addition. So also. So we want to factor, cancel common factors, and then multiply straight across. So what I'm going to do is factor my first numerator. I'm going to take a 7 out of 7x plus 7 and get 7 times x plus 1. And my denominator here, x plus 4, cannot be factored further. I think I'll just put it in parentheses because that's going to be a factor all unto itself. We can't cancel the x and the 4 separately. They go together, they're bound with that plus sign. Okay, this is multiplied by, this trinomial factored will be x, let's see, minus 5, x plus 4. And in the denominator, what can we do here? We can take out a 7, and then we have left x squared minus 6x minus 7. So we've got another step where we can factor this one. So let's rewrite this. We've got 7 times x plus 1 over x plus 4 times x minus 5 times x plus 4 all over 7, and now we're going to factor that trinomial, and it will be, what, x minus 7, x plus 1. Now, to multiply fractions, you just multiply the numerator, multiply the denominator, simplify, and you're done. But to multiply the top and bottom, I'm going to put this extra step, but it's really not necessary. I'm going to show you that if I multiply the top, this is what I have. All of those factors. If I multiply the bottom, this is what I have. But I don't really need to write that step. I can just do this cancellation back here, but I wanted to show you that. So now, what can we cancel? Well, 7 divided by 7 is 1, so that cancels and leaves behind a 1. 1 times everything else. We've got a x plus 1 and another x plus 1, so divide those, you get 1. X plus 4 and x plus 4, that leaves 1. So you've got 1 times 1 times 1 times x minus 5 all over, and what was left down here? X minus 7. So we have simplified, we've multiplied these two and given our answer simplified. All right, our last example for this part, this video, will be to divide rational expressions. So remember, a rational expression looks like a fraction with variables in it, and so we've got two fractions, one over the other, and we want to divide. So do you remember how you divide just regular old fractions? Okay, so if I had 1/2 divided by 3/4, let's see what that looks like. 1/2 divided by 3/4, what would I do? Well, I'd take that 1/2, and some people say change division to multiplication, and then flip the denominator. Have you ever heard that? Keep the 1/2, change division to multiplication, and flip the denominator. That's one way people remember that. And then what are we doing? This. We're just multiplying now. Straight across, simplify, we're done. Same thing here. We're going to keep it, change it, and flip it. And factor. Okay, so we're going to keep the a squared plus 2a minus 8 over 2a squared plus a minus 3, but we also need to factor those. So let's factor a squared plus 2a minus 8, and that would be what? A plus 4 and a minus 2. And then our 2a squared plus a minus 3, 2a plus 3, a minus 1. Foil that, you should get 2a squared plus a minus 3. Okay, keep it. That's like our 1/2. We're keeping that. We're going to change it to multiplication, but we're going to flip this one. So be careful here. This is my new numerator, 2a squared minus a minus 6. But I'm going to factor it as I write it. Okay, so you may want to draw little arrows or whatever to make sure you remember what we've done is we're flipping it and factoring. Okay, when I factor this one, I'm going to get 2a plus 3 times a minus 2. Foil that, I should get this denominator over, see I flip my 3/4 to 4/3. I flip this, putting this on the top, this on the bottom, and on the bottom all I can do is take out an a. That's the new denominator. Okay, just like we did before, I could rewrite this putting all these factors in one numerator, all these factors in one denominator, then cancel, but you can see that's not really necessary. We can just look for our numerators and denominators for matching pairs, right? So what do we have that matches? Well, we've got an a plus 4 and an a plus 4. That leaves behind 1. We've got, what else? 2a plus 3, 2a plus 3. Those cancel. Anything else? I don't see anything else. So we have a minus 2 times a minus 2, written more simply as a minus 2 squared. And what's left on the bottom is an a minus 1 and an a. I like to put the lonely a first and then the a minus 1. It's not wrong to do it the other way, but you typically will see it like that. Okay, we'll continue R.7 in the video labeled Part 3.